Now let's solve some word problems. We'll start off with this sheet of metal. It says that the length is twice the width. So what we'll do is we'll use x for the width, and that means the length would be 2x. Now it goes on to say that we're going to cut corners out that are 10 by 10. And it doesn't say, but it's implied, that we will fold along those lines and form a box. So for this box, then, we know that the length of this box is the length of the original sheet of metal minus the two 10-centimeter pieces that we cut out. So that'd be 2x minus 20. Likewise, the width of the box is x minus the two 10-centimeter pieces, which would be x minus 20. And when we fold it up, the 10 becomes the height of the box. The volume of a box is the length times the width times the height, which comes out to be this. To solve this, we will begin by dividing both sides by 10, and these 10s will disappear. And this will give 750. We will then multiply the 2x times the x, that's 2x squared, the 2x times the 20, negative 20, and that's negative 40x, and the negative 20 times x is negative 20x, and then the negative times the negative would be a positive 20 times 20, or 400. We can combine some things together. And we can gather all of our constants over on the left. Now, similar to what we did up in step 1, since all of these are even numbers, we could simplify this by dividing through by 2. And then, of course, we need to solve the quadratic equation. Now, we have a couple of choices in solving. One, we could try factoring. Those are some very large numbers to deal with. Or we could use the quadratic formula. Of course, the quadratic formula is very reliable. And if we have the quadratic formula on our calculator, it makes our work a whole lot easier. If you have the quadratic formula program on your calculator, you can go ahead and give that a try. There is the quadratic formula program. So if you want to try to put that into your calculator, you can pause the video and give it a try. When you run the quadratic formula program, you enter the A, B, and C just like you would use them in doing it by hand. And as you can see, we have two answers. Now, the negative 5 makes no sense in this context. So 35 has to be the width. And of course, we were told that the length is twice that, which would make 70. So have a look at this problem. And you see we want the lengths of the sides of this right triangle described here. So let's draw us a right triangle and label the shortest side by an X, which means that if you read the second sentence, the longer side is 10 less than twice the shorter, which would make 2x minus 10. And then the hypotenuse, which is the other side, and by the way, in case you're not up to speed on things, here's the right angle. Then the hypotenuse is the side across from the right angle. Anyway, that is 20 more than the 2x minus 10. We could simplify that to just 2x plus 10. So there is the relationship. The square of the bottom here and the square of the side here have to add up to the square of the hypotenuse. To solve this equation, we will first multiply things out. This will be 2x times 2x, which is 4x squared. This will be 2x times negative 10, that's negative 20x, doubled, which is negative 40x. And then negative 10 times negative 10 is positive 100. We'll write down the x squared. Similarly, when we multiply this one out, we will have a 4x squared plus 40x plus 100. We can subtract some things. For example, there's a 4x squared on both sides. If we subtract the 4x squared from both sides, that is going to disappear. We also can subtract the 100 from both sides. Now we can combine some things together. Here's the x squared, which we will leave alone. Then, if we subtract the 40x from both sides, we get a minus 80x. Now we can solve this one by factoring. We can factor an x out, set each of these equal to 0, and finish solving. So we actually have two choices for an answer. Either this property is 0 meters long, or it's 80. I don't think 0 makes any sense. So we'll choose the 80, which means that what we said in the beginning, the shortest side is the 80. And according to what we put, this side is going to be 2 times 80 minus 10. That comes out 150. And then the long side, the hypotenuse, is going to be 2 times 80 plus 10, which is going to be 170. In this last problem, we are given the equation that we're going to be dealing with. And it's just a matter of us comprehending what in the world do the variables mean. You can probably figure that out from the wording in the problem. A projectile is shot upward from the ground with an initial velocity of 73.5. Well, you can see where the 73.5 comes into play. Neglecting air resistance, it's height above ground. this many seconds after it's launched. So T represents the time. That makes sense. And S represents the height. That makes no sense, but that's what it is. So when we see a question that says how many seconds, we know that we are looking for the T. When we see 100 meters above ground, we know that that is the S. So this problem is a matter of putting the 100 in place of the S and solving for the T. So to solve this equation, we'll begin by putting it in standard form. In standard form, we need the T squared to be on the very front. We need the T to come right after that, on the left-hand side, that is. And we need a 0 over here. So when we move both of those terms over, we're going to get a positive 4.9 T squared, a negative 73.5 T, and the 100 is still positive like it was because we didn't move it. And so now we need to solve that equation. I don't think we're going to want to factor that. The quadratic formula, I can just imagine using these numbers and having to multiply all of that out by hand. So again, the best thing is to use the quad program on my calculator. So when I do that, notice I get these two answers. Well, that kind of makes sense. You know, we're launching this projectile. It's going to be going up and then coming back down. And somewhere here, after 1.5 seconds, it's going to be 100 meters high. And then later on, after it goes up and heads back down, it will again be 100 meters high. Now that's 13.5 seconds. To answer the question, how long will it take for the projectile to return to the ground, we just need to recognize, similar to what we were talking about in the previous problem, that the ground means the height is 0. So we're going to take our original equation and use a 0 for the S. And now we need to solve. Now again, we have a quadratic equation to solve. Now this wouldn't be near as bad as the previous one. However, we're on a roll with our calculator. So we will take out our calculator and run our quadratic formula program. Notice for the C, the constant, the number, we use a 0 because there's not one. And so again, this should make sense in light of what we were discussing earlier. In the beginning, after 0 seconds, before we actually fired the projectile up into the air, is when it was at ground level. Then it went up and down, and 15 seconds later is at ground level again. So 15 is our answer.